Okay, so we're going to take notes on section 1-2, day 1. And if you look at the 1-2, day 1 stuff, we're talking about I will be able to represent functions numerically, graphically, and algebraically. Determine the domain, implied and relevant, and the range of a function. I'll read the rest, but we're going to do that tomorrow. Okay, now today we're looking at functions, and we're talking about a function as a relation between two variables whereby each independent variable in the domain maps to no more than one dependent variable in the range. Now, this idea of functions being one-to-one, for every input there is exactly one output, is important to keep in mind. Now, we got a function machine. You probably saw this the first time. It's like, oh wow, look at that cool thing in my textbook. It's a picture. It doesn't do anything fancy. We put in our x and out comes our y. We put in our domain, out comes our range. We put in the independent variable and the output is the dependent variable. Okay. Now, I'm not saying anything that you guys don't know. But using mapping diagrams below, determine if it is a function. Remember I said it's one-to-one. For every input, there's one output. So this idea of input with one output, if I put in x sub 3 and I get y sub 3, and I put in x sub 4 and I get y sub 3, that's okay. For every time I put in that x sub 3 and the x sub 4, I get out just one value. Okay, so this is going to be a function when I'm looking at this. But in the other picture here in B, I'm looking at this idea that I put in x sub 2, I get y sub 2. I put in x sub 1, I get y sub 1, and I put in x sub 1, I get y sub 3. Two different outputs for the same input. Well, that's not a function. So that's how we're going to be defining this function stuff. And you guys kind of have that extra look, you know, behind the curtain, because you know what the vertical line test is. It's not like I'm going to surprise you and talk about this new improved thing, this fandangled thing. We're going to talk about that in a few minutes. But right here in example 1, defining a function. Does the formula y equal x squared define y as a function of x? Well, if I look at the numeric, graphic, and analytic stuff about this function, we can represent a function numerically, graphically, analytically. For instance, the following all represents the same function relationship. Okay, and it's the one that's above. But you're thinking, if I just look at the parabola itself and what it looks like, and I use my skills from last year when you brought in that vertical line test, completely and totally meets all the criteria to be a function. Okay, for every input, there's one solid output for that side. So yes, every x is paired with no more than one y value. If it does have more than one y value, it's not a function. Okay, let's flip in the page. Now, I want you to try this, but remember, when you see numbers and you're jumbled and you're looking at stuff, you kind of get confused about things. Determine if the following represents functions. If not, explain why. A, we got a domain, we got a range. Our domain goes in, our range comes out, and here there's a one-to-one correspondence, meaning for every domain there is a range that's unique to that domain. Okay, so this is going to be a function. Yes, it's a function. Each input has a unique output. Okay, in this next one, I always got people going, oh, boom, this isn't a function. I want you to think of what this might look like. Okay, if I go out horizontally -3 and then go down -6, and I go horizontally -2 down to -6, and I go horizontally -1 down to -6, and 0 down to -6, and 1 down to -6, what's this function going to look like? Yeah, it's just going to be a line. It's going to be down here, 1, 2, 3, 4, 5, 6, and it's going to be a line going across like this. So that's my line coming through. So that's what I'm looking at, and that's going to be a function. It's a horizontal line, but it's going to pass my vertical line test for sure. Now in C and D, I want you guys to come up with it. Go ahead and go after C and D. Now in C, I'm looking at this and I've got this as not being a function, okay? But in D, I've got this thing going on that 16 doesn't have a value, doesn't have a range, okay? So I have a discontinuity, okay? But I can still call it a function. I just have a discontinuity in this function, okay? So it's got a hole in it or something, okay? So it can be a function. Each input has a unique output. It's just that 16, there isn't an output there because there's a hole at that spot for whatever reason. And we'll talk about that tomorrow. Now in E and F, I kind of underlined the things that are the same. That's the only place it's going to fail. If you have a list of numbers for SAT, ACT, MCA, if they give you a list, are these values from a function or not? Okay, look for your X values that are repeated. I'll look for the X values that are repeated. I underlined them for you so we could find them. Is it the same value or different values? Okay, both of them happen to be different values, so both of them are not a function. Okay, it is possible for them to repeat an X value and to have the same Y value in both coordinates. This to show that, hey, it's repeated, so it's not like, every time an X repeats, it's always not a function. It has to be a different output, okay? Every time you put in a domain value, you should get the same range value. Now, graphically, from the information we got here, you decide which one of the three is a function or not, and put the letter right there after the question mark. And then how can you tell? And then how can you tell? Now, hopefully we're looking at, and some people, well, I really don't know. And I'm always told I should probably pick C when I'm not sure. It's not always that way, but it happened to be on this one. And why? Okay. At X equals 0, I have multiple values. I have 0, 0, 0, 0, 2. I have 0, 0, 0, -2, and 0, 2. And for those folks at home, I just started pointing at the board like you could see me pointing. I had to make sure I colored it in so you could see what I was doing. Are there any questions on why this isn't a function? We're okay with that? Now, as I've alluded to, we got the vertical line test. And because of the vertical line test, I can not only shortcut my reasoning for why something's a function, it's just so much faster. I can just visually check with my visual vertical line going across to see if it's a function or not. And if it crosses twice, it's not a function. Okay, so in a vertical line test, a graph or set of points x, y, and the xy plane defines y as a function of x if and only if there's no vertical line intersecting the graph in more than one point. Okay, just one spot all the way along. If it's not, then it can't be a function. Now, I have my handy wand, the wand of function. Okay, right here, as I go through, you guys determine them. And I'll just keep running my vertical line all the way across, and you make the determination based on the passing of the vertical line. Okay, so now, because we've got this going on, A's function, B's not a function, and C is a function. Okay, Vertical line crosses at one spot. When it doesn't cross at one spot, when it's more than one, it's not going to be a function in the same area. So D, E, and F, go. By the way, for F, I didn't think your notes had it really clearly stated. We have it colored in here. That's closed dot on that graph. And this is an open dot on that graph, an open circle, okay, when you're looking at that. So now make the determinations. Function or not. So I'm looking at this, I go across. Okay, it's crossing at one spot. Here, still crossing at one spot. Here, it looks pretty good. See, this is a, I've got a value for X, but my Y value, you know, it's kind of a jump out here. I don't have that, it's a discontinuity at that point. Here, it looks like I'm crossing at two parts, don't it? But this is colored in and this isn't. And this would be considered a function because it's only one spot. At 0, my value's there. It's not down there. So consider what's going on. We're going to be looking at piecewise functions, step functions. Yes, sir. Yes, because it was closed or open. Now, if they're both closed in letter F, it would not be a function because I'd have two things that were connected to it. If they're both open, it would be a discontinuity. Okay, being that they're both open, I just have like a hole at that point in that function. Okay, and I'd still be able to have, I just don't have a value at 0, 0, but outside of that, it's still that other. So I can talk about my domain not existing at those spots. Okay, does that make sense? Nope, it wouldn't. As long as they were opposite like that, it would still work as a function. Any other questions? Okay, now, let's redo this one here. In correcting the test, I was thinking about this problem as soon as I read this next statement. In order to graph the equation, you have to have the equation explicitly solved for y. This means you have y by itself on one side and an expression on the other side that has no y's in it. Now, when I have people do this, they kind of, you know, whether it be that they're rushing or they're not paying attention to what's happening, when you're solving for y, you got to make sure you get everything set up. I'm going to add 16. I'm going to divide by 7. Okay. Now, at this point, I'm going to take the square root of both sides. So I've got y is equal to plus or minus 4 the square root of 7 times the square root of 7 over the square root of 7. Okay. So I've got my plus or minus 4 the square root of 7 over 7. Now, that's my answer for this. But I would have people do some interesting things. At this point, they decided to take the square root, and then amazingly, 7 restricted the square root from happening to itself. It was like square root kryptonite. It couldn't work. When you take the square root of both sides, you can do it that way. You just got to make sure you take the square root. And then you continue your solve. And remember, that's a plus or minus, so it's a plus or minus 4 over the square root of 7 times the square root of 7. And you could do it this way. It's just not as neat. But remember, when you take the square root, you got to make sure you take the square root. You can't just say, well, you know, these guys are going to be under that rule, and these guys, well, you know, I really like them, and they don't need to be under that rule. Be careful about your notation. Be careful about your work when you're doing things. Okay, with that, whenever I put anything in my calculator, I have to have it y equals. Okay, So here, I'm going to subtract 3x. And then after I do that, I'm going to take the square root of both sides. Well, I got y equals plus or minus the square root of 6 minus 3x. And here's the big indicator, huge monster indicator, that it's a function or not. When I put one value of x, my domain, into this function, I'm going to get out a plus or minus of whatever the evaluation is. Well, that's two values for one, two y's for one x. I can't have that. So it's not a function. For every x, there's two y's when it comes out because of the plus or minus. Because when I take that square root. Now, when I'm solving and I have y in a couple terms and I can't combine those terms because they're different variables, I have to pay attention to the fact that I've got those y's going on here, and I'm going to subtract just the 4. I'm going to get the things with the y together, so I'm going to subtract 4. Well, I'm doing this completely and totally factor out a y. Okay, I'm going to factor the y out. So when I do that, I'm going to factor y out. 2x squared minus 8 is equal to 7x minus 4. After I factor the y out, I now can divide by 2x squared minus 8 on both sides. And now my y is all alone, and I can even put this function into my calculator because I was able to dig that out, and now I can see what that picture of the function looks like. But it's implicitly defined for y. We okay with that? Okay? When I come across things in C, I got y to the 4th power. I can do this at the 4th root. I think I already got this on set. So I can take 4th root, got my index, plus or minus. But for every x I put in, how many answers will I get out? 2. And even, I've got some people, yeah, but Bloom, what if you do it that way? It still will be the same. You know, this is the 4th root still, okay? But I'm still going to get 2 y's for every x, so it's not a function. My next one. If I was going to solve this one for y, what would I have to do? I would have to square it. So if I square both sides, I get x squared equals y. Okay, well that's a parabola. Okay, but now this is unique. Okay, because I've got to think about what that might look like. Because is it really a parabola? Because in the original function, can I put in a negative value? Now the restriction on the original function is if y were negative to get an x, you know, why there are no negative values that go in for my y when I'm looking at that. Just thinking about this, just to make sure I'm thinking about this right. So if I take a negative x, negative 4, how can I get that to be the square root of what value for my y value? I can't put a negative value in and get the square root of some y out to be that negative. So I've got to consider this is a function, but it's only on the right side, okay, for my x values that are positive. When I do this, because of the restriction with that square root. Just because it's that square root in there. The square root's funky with it. Because you've already seen it, as a parabola. Okay, because it's not true with all y equal x squared functions. It's only true with this restriction. I mean, if I just knew that, then my function does that, it's the whole thing, there's no restrictions on it, I'm fine. Okay, and maybe I gotta move that, okay. but just make sure you're aware that we have to consider those restrictions when we're doing this as well. Okay, so we're looking at domain and range. Note, when a function is described algebraically, use the formula to determine the implied domain. The implied domain is just the way the equation is. It'll work all the time, okay? Implied domain for what I have here as an example, sphere volume, 4/3 pi r cubed, right? When I consider that formula, I could use negative values to positive values. So negative infinity to infinity is the implied domain. But when we talk about relevance, does it make sense that I would use a negative value for my radius? Okay, my radius can be anywhere from 0 to infinity. So that's where we're talking about relevant. And we have to what makes sense for the situation? Okay, that's the difference between our implied domain and our relevant. Implied domain comes from just the formula. You're looking at it, or the equation. You just look at it and say, okay, it'll work from here to here. But then you look at the actual situation, okay? And that's what makes sense for the situation. That's when we're talking about the relevant domain. And I use that example for volume of the sphere, so we can slide on here. Okay. Now, to find the domain of a function algebraically, we must look for values of x that don't work, okay, and exclude those from the domain. And we got to watch for division by 0, taking an even root of a negative number. We got to look at square roots, especially because they've got to be 0 or positive. You know, we don't really have that square root of a negative value. My example here, so I'm looking these over and clean up my board a little bit, and I'll explain my arrows in a second. X plus 3, it can be 0, but it can't be negative. So x plus 3 has got to be greater than 0, greater than or equal to in this case, okay? Because I can take the square root of 0, I can take the square root of 1, I can't take the square root of a negative anything, okay, without I, okay? But we're assuming that these are going to be real number answers. So when I solve this, I get x is greater than or equal to negative 3. Well, my set builder pretty much puts that right in there. My interval notation states that x is greater than negative 3, so it's boxed at negative 3 and goes to infinity. Now, it's interesting when I'm looking at fractions and the way these are set up, and I have the square root of x over x minus 5. Okay, so I've got the square root of x over x minus 5, and I'm considering this. I have a restriction created by the square root of x. My x values, my domain values, have to all be greater, 0 or greater, okay? So I know that because that has to exist, and that's where this arrow is coming from. That's completely and totally writing that part of my domain restriction. X minus 5, well, I know x minus 5's got a issue at 5, and that's the other part of my domain restriction, okay? When I'm looking at that, I mean, I can't divide by a 0. So my set builder will talk about being greater than 0 but not 5. And my interval will go boxing at 0 to 5, okay, and then from 5 to infinity. Now, in C, I want to emphasize that that is not A times S. That's A of S. It's in function notation. I know we're used to seeing F of X or F, or G of X or something, but that is A of S is equal to the square root of 3/4 S squared. Now, what that is A of S is the area of an equilateral triangle with sides of length S. Okay. This equation itself works anywhere. S could be any value, okay? Now, and when I'm looking at this idea, I'm talking about the implied value. It could be anything from negative infinity to infinity. But because now I know it's the area of an equilateral triangle with the sides of S, can I have a side length that's negative? No. So my relevant domain forces this. So therefore my set builder and my interval would look like that. Okay, and remember, I'm bringing back set builder and interval. We're going to use it a lot in this chapter. I just want to make sure you're comfortable with using both. Now, what we've got going on here is I'm going to do 2 problems, and then I'm going to have you guys do the remainder of this side of the sheet while I'm handing out your tests, okay, and finding out who's here and who's not today, the way it is. After I do that, I'm going to do 1 more of the ones that are on this page, and actually we'll probably do that one before I even start handing it out so I don't have to worry about rushing back. I want to talk about our domains, okay, and being clear about our notation. So in A, if I'm doing this, I'm going to factor out, and I've got x squared plus x minus 6. And I want to factor x plus 3, x minus 2. Well, this means I have negative 3 and 2 as my answers that are restrictions. So x plus 3 equals 0 when x is equal to negative 3, and x minus 2 equals 0 when x is 2. Now, if I put this in my set builder domain, bring that up, actually get that out of my way. But when I do it in interval, the only restrictions I have are negative 3 and 2. So I go from negative infinity to negative 3, and from negative 3 to 2, and from 2 to infinity when I write this interval in interval notation. Now I want you to be comfortable with that. Now I know typically we'd go to B, but I'm going to go down to C real quick. No, instead of C, we're going to go D. We'll do D and F, and then we'll finish those out. So when I'm looking at D, there's a lot of things going on, but the part that is going to affect my domain, okay, the things that I can put in, is underneath the square root. The square root has to evaluate as 0 or larger, okay? So 3 minus 5x has to be greater than or equal to 0. So I go for the solve, I divide by negative 5, and I find out that x is less than or equal to 3/5. So 3/5 is the largest value for x that can go in there. So from negative infinity to 3/5, and including it will be okay. Set builder and my interval notation. Now it makes sense why I did what I did. Okay, now I'm going to hand out your tests. You guys go ahead and just work on the ones on this page. Consult, and I'll have the answers come out, and we'll read those test answers too. Okay, so if we go on and look at our next one here, after we do that first one, we got the second one, and we're talking about the fact that we have x squared minus 16. And we have this, and I can factor out the x plus 4. And now keep in mind when I factor something out from the original, the 2 equations, This one, y equals 3 divided by x minus 4, and this one, or gx, excuse me, should have the same graph. Okay, but now the restrictions, I still have to look at that x plus 4 because that was in the bottom. So my restrictions should be x cannot be 4 and negative 4. So now I write that in my interval notation and my set builder. Now every time I have a square root, I have the restriction that it's got to be 0 or greater. And so I'm looking at 2x minus 3 is greater than or equal to 0. And I find that 2x is greater than or equal to 3 and that x is greater than or equal to 3 halves. So now I've got my set builder restriction and my interval notation restriction. Now, keep in mind as we're looking at these are all on the main line. They're not denominators. So I can have them be 0 and still work out. If I'm looking at D, my restriction is 3.5x, and so it's got to be greater than or equal to 0. I solve and find out that x is less than or equal to 3/5. Well, in set builder, that's straight up. X is less than or equal to 3/5, just like that. And in interval notation, I go from negative infinity to 3/5 boxed. My last two, I've got some interesting restrictions when I have a square root on top and things in the bottom. So first I'm going to factor anything up. The square root on top of x minus 5 and x plus 2. Because of the x minus 5 and x plus 2, I can't have it be 5 and I can't have it be x equal to negative 2. But because of the square root, that's another part of my restriction. I can't have the square root be 2x, it's got to be positive, so 2x minus 1 is greater than or equal to 0. So 2x is greater than or equal to 1, and x is greater than or equal to 1/2. So now my set builder has to reflect that. So x is greater than or equal to 1/2. Now, be careful. X has to be greater than or equal to 1/2, but that doesn't include the negative 2. So you're going to see in my set builder that x is greater than or equal to 1/2, but can't be 5. I'm not going to say a word about 2 because it's not in my domain for this function. And I'm going to do the same thing for my interval notation. So pay attention to that. And in my last one here on this page, I've got 6t all over 4 minus 7t. Now, when I do this, my restriction isn't about 6t. It's about 4 minus 7t, square root of that. So I've got 4 minus 7t is greater than 0. And it's greater than 0 because it's in the denominator. And I can't have a 0 in the denominator. So that's why it's not or equals to. Now, 4 is greater than 7t, and 4/7 is greater than t. And now I've got my set builder, and I've got my interval notation. Hope things are going well. This is day 1 of 1.2 notes, and we'll see you the next time you're in class.